Hi guys, there is a question from section 2.8. Section 2.8, the problem is number 87. One of the students had a question about it. Let me first of all explain to you on these problems, the one that they asked for composition, the F composed with G and G composed with F. You don't have to worry about the domain of these composition. They do get a little technical. And really, unless you need more math, you probably don't have to worry about that. Now, we will talk about domain in section 3.1, next chapter. But those are very simple function. But composition of function can get a little tricky when it comes to the domain. So in the exam, I'm just going to ask you to compute the composition. I want to ask for the domain of these types of functions. These are the so-called composition, okay? So for now, make sure you can do composition. Now, if you do need more math, and you really don't understand how to do the domain of the composition, let me know, and I can always communicate with you directly, okay? But for those of us who, this is probably their last math, I'm sure you wouldn't have to worry about composition, domain of composition, okay? So let's just find the composition itself, because that's what I'm going to ask you in the exam, just to compute the composition, okay? So, because I know the student had a question about the domain, but, well, of course, domain basically means all the numbers that the function makes sense. But when it comes to composition, it does get a little bit tricky, okay? So I wouldn't worry too much about that right now. So we're given two functions, f of x, which is 1 over x minus 2, and g of x, in this case, is going to be 1 over x, okay? And so let me start with part A, which they want to know. By the way, the way you read that is f composed, that whole, not a dot. Dot means multiplication, the open hole means composition. So you read that as f composed with g of x, okay? Let me read that one more time, because it's the only way you read that correctly. F composed with g of x, okay? Now, as you know, I'm sure if you read the section, definition of that is f of g of x. That's the step number one, to know the definition of f composed with g, which is f of g of x. So you always start from the inside function, which is g, and you replace it with what g is in this example, okay? So our function inside is g, and our g in this example is 1 over x. So the next question becomes, what is f of 1 over x? So the first step is always to replace the inside function with what it is equal in your problem. The last question is, what is f of 1 over x? Well, of course, f of any x is 1 over x minus 2. So remember what I told you in the last video, whatever shows up inside the parentheses, that's your x. So all your x is going to be replaced by that. Of course, our x is now 1 over x. So we're going to replace this x with 1 over x. So let me just replace it. And the last step is a little bit of simplification, because I'm sure you know we cannot leave the answer like that. It's actually called a complex fraction when you have more than one fraction line. So we're going to have to combine this to a single fraction. So first step, we're going to write 2 over 1 instead of 2. We're going to combine these two into one single fraction. Of course, between x and 1, the least common denominator is x. So we're going to multiply. So we're going to combine these two fractions to a single fraction. We have to have the same denominator. So between x and 1, the LCD, the least common denominator, is x. So we're going to multiply top and the bottom of this fraction by x, so we can create the same denominator. So now that becomes 1 over. Now that you have the same denominator, we can combine into one fraction. That's the reason why we did that. And then also, we're going to, let me just move this up so you can see a little bit better. And now here, we're just going to combine the numerator, which is 1 minus 2x, okay? So now again, we still have to have two fraction line. As you know, in algebra, 1 over any fraction is its reciprocal. So 1 divided by any fraction is just reciprocated, which means it flips it. So finally, the final answer should be, we're going to reciprocate the fraction, so it just becomes x over 1 minus 2x. Okay? So x over 1 minus 2x is your part A, f composed with g of x. Again, obviously, I'm not going to ask for domain, but obviously in this case, you will realize that domain basically means what makes the function make sense. So in this case, the only number that is no good is actually 1/2, because if x is 1/2, 2 times 1/2 becomes 1, and of course 1 minus 1 is 0. As you know, you can't divide by 0. But don't worry too much about domain of these. I will not ask for domain of composition on the exam. Now, we will have some issue of domain next chapter in section 3.1, but those are pretty straight shot, okay? So there is your f composed with g. Let me do the g composed with f also. So same function, except we're going to do g. So the order is going to be reversed. So for g composed with f, this is part B. So now we're looking for g composed with f of x. And again, same definition, except this time it's going to be g of f of x. So your inside function is f of x. So as we said in a minute ago, we're going to replace the inside function with what it is equal to. In this case, of course, is 1 over x minus 2. So now we're looking for g of that. Of course, g of anything is 1 over that. So in this case, it'll just be 1. I'm sorry, let me put this up a little bit. So again, we're looking for part B G composed with f, which is by definition G of f of x. And as I said a minute ago, we start from the inside function, replace it with what is equal in this example, which is 1 over x minus 2. So now we want G of that. Of course, G of anything is 1 over that. So G of this is 1 over that. And as we said also a minute ago, 1 over any fraction. Is this reciprocal? So as you reciprocate 1 over x minus 2, you basically get x minus 2. So x minus 2 is your, let me just make sure you can see it. So as we put 1 over x minus 2, then of course it reciprocates because 1 over any fraction is just reciprocal. So the final answer for G composed with f is x minus 2, okay?